Hello Excel VBA users, in this video, we're diving into the powerful world of Excel VBA functions. They are an essential tool in VBA programming that can save you time, enhance your macros, and improve code reusability. In this video, we'll explore the benefits of functions, understand their syntax, and discover practical examples that showcase their usefulness. So let's jump right in. Functions offer several advantages that greatly improve your coding experience. Firstly, they promote code reusability. Instead of duplicating code across multiple subroutines, we can encapsulate common calculations or actions within them. This saves time and effort, ensuring consistency throughout our macros. Additionally, functions enable modular programming. By breaking down complex problems into smaller, manageable pieces, we can design functions that perform specific tasks. This approach enhances code organization, readability, and maintenance, making collaboration with other developers easier. Functions also allow us to focus on the task at hand without worrying about the underlying implementation details. By encapsulating complex calculations or actions within functions and giving them meaningful names, our code becomes clean, concise, and easier to understand. Excel VBA provides a wide range of built-in functions that simplify coding tasks. These functions cover various categories, such as mathematical operations, string manipulation, date and time calculations, and more. They are readily available tools that can significantly enhance the functionality of your macros. In addition to built-in functions, you can create your own custom functions in VBA. Custom functions are flexible and tailored to your specific needs. You can define functions to perform calculations, manipulate strings, handle complex data structures, and more. This flexibility empowers you to extend the capabilities of Excel and automate tasks efficiently. Now let's move on to practical examples that demonstrate the usage of functions in Excel VBA. Imagine you frequently need to calculate the average of a range of numbers in your macros. Instead of duplicating the code in multiple subroutines, you can create a custom function called CalculateAverage that accepts a range as an argument and returns the average value. In this example, we are creating a custom function called CalculateAverage that accepts a range of cells as an argument and returns the average value. Let's break down the code and understand how it works. First, we declare two variables, total and count, which will be used to keep track of the sum and the number of cells in the range. We initialize total as a double data type and count as a long data type. Next, we enter for each loop, iterating through each cell in the given range, RNG. Inside the loop, we update the total variable by adding the value of the current cell to it using cell.Value. Similarly, we increment the count variable by 1 for each cell encountered, keeping track of the number of cells processed. After the loop completes, we calculate the average by dividing the total by the count and assign it to the function name CalculateAverage. Lastly, we specify that the function's return value is of type double, using as double. By utilizing this function, you can easily calculate the average value of a range of cells without duplicating the calculation logic in multiple subroutines. This promotes code reusability and ensures consistency in your macros. Let's explore another example that demonstrates how functions can be used for string manipulation. Suppose you often need to reverse the order of characters in a string. You can create a custom function called ReverseString that accepts a string as an argument and returns the reversed string. Let's break down the code and understand how it works. First, we declare two variables, reversedString to store the reversed string and I as an integer variable for iteration. We use for loop to iterate through the characters of the input string from the end to the beginning. The loop starts at the length of the input string and decrements I by 1 in each iteration until it reaches 1. Within the loop, we use the mid function to extract each character of the input string. The mid function takes 3 arguments, the string input string, the starting position I, and the number of characters to extract, in this case, 1 character. Each character extracted using the mid function is then appended to the reversedString variable using the concatenation operator, and this process continues for each character in the inputString, effectively reversing the order. Now I must warn you, this next part might be a bit of a mouthful to say, but bear with me, we'll get through it together. After our loop completes its backward journey, we take that reversedString, stored in the slightly tongue-twisting reverseString variable, and assign it to the function name reverseString. What a mouthful, but hey, in the programming world, we love a good challenge. By utilizing this function, you can easily reverse a string without having to write repetitive code in multiple subroutines. The function encapsulates the logic for reversing the string, making your code more modular, reusable, and maintainable. Next, we'll explore the usage of functions within subroutines and understand their practicality, particularly when dealing with multiple subroutines. Functions come into play by enabling us to call them from subroutines, allowing us to carry out specific tasks or calculations and obtain a result that can be utilized within the subroutine. To call a function from a subroutine, it's as simple as using the function name followed by parentheses, along with any necessary arguments. Once invoked, the function executes and returns the result back to the subroutine. Now, let's take a look at an example to see this concept in action. Let's first move the function from Module 1 to Module 3 for clarity. Here we define a subroutine called MySubroutine. We create a range object RNG and assign it the range of cells A1 to A10. Then, we declare a variable AverageValue of type double. We call the CalculateAverage function, passing the RNG range as an argument, and assign the returned value to AverageValue. Finally, we display a MsgBox showing the calculated average value using the MsgBox function. Now let's enter some values in the range A1-A10 to test the subroutine. With the values entered, we are ready to execute the MySubroutine and calculate the average. And there you have it. The subroutine has successfully calculated the average value of the entered range by employing the function. It showcases the seamless integration of the subroutine and the function, working together to provide us with the desired result. By utilizing subroutines and functions together, we can streamline our workflow and achieve efficient results. It becomes clear that functions are incredibly useful when you have multiple subroutines that require the same calculations or actions. Instead of duplicating the code within each subroutine, you can write the code once as a function and call it from multiple subroutines. This saves time, promotes code reusability, and ensures consistency in your macros. That's it for this video on Excel VBA functions. We covered the basics, including the syntax, creating custom functions, and calling them from subroutines. I hope it became apparent how functions not only enhance the power of your macros but also promote code reusability and maintainability. By utilizing them, you can streamline your coding process, save time, and ensure consistency throughout your macros. Thank you for watching. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe for more tutorials. Happy coding, and I'll see you in the next video.